Hi everyone, welcome to another Leetcode problem discussion. Today's problem is problem 2055, plates between candles. So you can see a big description here. So I will just try to shorten it and explain to it. So basically you are given an string array or array of characters. You are given a string. The string has just two types of characters. One is this sign, and the other one is this star sign. So this one represents candles, and this one represents plates. Okay. So what you have to do is you will be given some queries. So queries will look like a pair of values. So suppose 2, 5. So you'll be given some queries, and what you have to do is you have to find all the plates that are between candles. Okay, so let me show you one example. So here you can see this is your given string, and this is your query 2, 5. So what you have to do is starting from character 2, index 2, up to index 5, what you have to do is you have to find all the uh, plates uh, that have at least one candle on each side. That means we have to find all the plates within the candles. So here, those plates are these two, right? So the answer is 2. Okay, so the answer for this is 2. And then for the second query, you can see that the indices are 5 and 9. So 5 and 9. So basically, within this window, we have to find all the plates that are within between candles. So as you can see, these plates are between candles. So there are like 3 of them. So answer for this is 3. Okay. Let me formulate another one. So let's say if a query was something like this, 1 and 9. Okay. So 1 and 9. So what you had to do is you had to find all the plates that are between candles. Now you can see that this plate is not between two candles, but everything else here is between candles, right? So there are 5 of them. You can see we have another candle here. Not necessarily everything is a plate, but these 5 plates are actually have 2 candles on both sides. Okay, so that's our problem. Okay, so let's try to find a solution for this. We can think about a naive way, and I would suggest everyone to think about the naive way. Okay, so let's look at the query. Okay, 117. So the query is 117. So if you have already thought about it, I suggest you pause the video and think about it. How can you find all the plates between 1 and 17, right? So that means within this, we have to find all the plates that are between candles. Okay, so if you have already thought about it, I hope you have found something. You have found a way. And let's discuss that, and then we'll talk about the optimized solution. So obviously what we can do is we can actually start reading from the left until we reach a candle, right? So we reach a candle, we say this we can say the leftmost, right? So this is the leftmost candle. So we find the leftmost candle, and then we again start reading from the right, and then until we hit a candle. So we can say that the rightmost candle is at 16, right? So that leftmost is at 3 and the rightmost is 16. So what we can do is we can just now start reading from 3. We can start reading from 3 and count the candles until we reach 16, right? So it's simple. We will keep on counting the candles: 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the answer for this is going to be 9. Okay, so it's quite simple, right? So we find the leftmost candle, we find the rightmost candle, and then we count all the candles between the leftmost and the rightmost. Obviously, we cannot just say 16 minus 3. That's wrong. The reason for that is between 16 and 3, there are not everything is a plate. You can see we have other candles, so that's why counting is important. So what was the complexity of this algorithm? As you can see that we have actually, in the worst case, we have to read through the whole array, right? So that if the length of this array is n, then in that case, these particular one took order of n time. And if we have like q queries, then it would be q into order of n. So for q queries, it will be qn, order of qn algorithm. Now let's think if we can optimize it a bit. So why don't we try to remember all the nearest left candles as well as all the nearest right candles, right? Okay, so here is the thing. Let's say, okay, so basically this is the answer. So we know that the query is 117. So if someone told me that what is the uh, nearest right candle, so I call it nearest right in R. What is the nearest right candle of 1? And what is the nearest left candle of 17, right? Or we can write it as nearest right candle. Let's write like this: nearest right candle of the left index, and nearest right of the right index. Sorry, nearest left of the right index. If we could just save it somewhere, in that case, it would have been easy. As you can see here, the nearest right for the left candle, nearest right for this is 3. Nearest right for the left index is 3. And nearest left for the right index, is 16. So this is the 16, okay? So this is the nearest left candle for the right index. Okay, and then if we could somehow also keep like memorize this count of plates, then it would be even easier. So if someone says, hey, I have say x plates till 16. So if someone says I have x plates till 16, and if I know that there are like y plates till 3, then I can just I have to find the plates between 3 and 16, right? So someone says I know that there are like y plates between 0 and 3, and then I also know that there are like x plates between 0 and 16. So what we can do is we could just do x minus y and find the number of plates, right? So we have to do just one round of pre-processing, and then from there on, it's easy to solve it. So for that, we need like 3 arrays of size n. So this is the left array, this is the right array, and this is the, suppose we call it plates array, right? How many plates are there? Okay, so the left array uh, actually saves all the leftmost, uh, the nearest left candles. So let's fill that up. For the first index, you see that we don't have any left candles, so it will be -1. Let's put -1, -1, -1, and then for this one, its nearest left is itself, so it's 3. For this one is also 3. It's also 3. Now for this one is 6. 7. The nearest left candle is at index 6. Same here, same here, same here, same here. Now 12, and then 12, 12. This is 15, 16, 16, 16, 19, and then 19. Okay, so this is the indices of the nearest left candles, right? Okay, now let's find the indices of the nearest right candles. We have to start from the right. Okay, so there is nothing in the right, but this one has itself is nearest right. 19 will also go there, 19, then 16, 15, 15, 15, 12, 12, 12, 12, 12, 12, 6, 6, 6, 3, 3, 3, 3. Okay, so these are the nearest, the indices of the nearest right candle. Okay, and then goes the plates. So plates, how many plates we have so far here? 1, 2, 3, 3. This is a candle, so no plates will be added. 4, 5, 5, 6, 7, 8, 9, 10, 11. Sorry, I made a mistake. So it will be 10 because it's a candle. 11 plates, 12 plates, 12 plates, 12 plates, 13 plates, 14 plates, 14 plates, and 15 plates. Okay. Okay. Now, what was our query? The query was between 1 and 17, right? 1 and 17. So between 1 and 17. Okay. What is the nearest right of 1? Nearest right of 1 is, you can see here, the nearest right of 1 is 3. Okay, so this is 3. And what is the nearest left of 17? So let's go and check the nearest left of 17. So this is 16. You can see here, right? Okay, 16. So what are the number of plates between index 16 and index 3? So you can see it, so number of plates is going to be the number of plates between index 16, which is 12 plates we have up to index 16, and then up to index 3 we have like index 3 we have like 3 plates, right? So 9. So that's our answer. This is 9. Okay, so now you can see it has been optimized much. Calculating this takes order of n. This also takes order of n, right? So this also takes order of n, and this pre-processing is done just once. So what is the time complexity? And you see, for every query, what we have to do is we have to just do like 1, 2, and 3 calculations. So every query just does 3 calculations, that's it, or 3 lookups. So time complexity is, initially we do the pre-processing in order of n time, and for doing like q queries, it's order of q, right? Because in every query we just do constant number of operations, so it's order of qn. You see that? So before it was order q plus, oh sorry, big mistake. Before it was order of qn, now it's order q plus n, a big improvement. And what is the space complexity? Obviously, for pre-processing and to save these values, we have to keep all these spaces. You can see we have a 3 arrays of order of n, so it's order of n. Okay. Okay, so now let's talk about a few edge cases. So you can see for the first one, right? For the first one, for the first query here, between 4 and 5, right? So between 4 and 5, you can see that the force, okay, so between 4 and 5, the nearest left for 4 is 6. Sorry, nearest right for 4. Nearest right for 4 is 6, and nearest left for 5 is 3. Okay, now what we have to do is we have to subtract from this to this. That means 3 minus 6, you can see it's minus 3. So that's not allowed. It has to be greater than 1. But now it's minus 3. So that means the result for this is going to be 0. Okay, that's the first thing. And then let's take a look at the second example, between 14 and 17. Okay, so let's see what is the nearest right for 14. Nearest right for 14 is 15. And nearest right for 17, nearest left for 17 is 16. So it's 16, right? Okay. So we know that from left we have to, so 16 minus 15 is 1. It's positive, but it's not greater than 1. That means the result here is also 0. As you can see here, between this and this, there is no candle. Okay, so this is important. Like the nearest left minus the nearest right of this, it has to be greater than 1. Let's look at another example, say 5 and 11. So for 5, the nearest right is 6. And for 11, the nearest left is also 6. Okay, so 6 minus 6 is 0. So there are even not 2 candles. Okay, so it's 0. So it doesn't satisfy this condition. And the final one is queries between 15 and 16. You see the nearest right of 15 itself is 15, and nearest left of 16 itself is 16. So 16 minus 15 again is just 1, and there is nothing here, right? So here is the formula. That means if I subtract from this, if I subtract the nearest right of the left pointer from the nearest left of the right pointer, then it has to be greater than 1 to have at least 1 plate in it. That's important. And the other thing, let's say another query. Let me show you another query. So the query is 0 and 2. Okay. So what is the nearest left, nearest right of 0? Nearest right of 0 is 3. And nearest left of 2 is, well, there is no nearest left, so it's -1. Okay, so if you see that if any of these is -1, then you can immediately say that the result is 0. That means one of them doesn't have any boundary. Okay. Okay, so for the code, you can see we have these 3 arrays for pre-processing: left, right, and plates, and all of them has the length equal to the length of this string. And then we have like Q queries, right? We have Q queries. So we have a result of size, and we have to return an array of result. So the result will be of size of the queries. For each query, we'll have one result. Okay, so for the pre-processing, we initialize everything with -1, as I showed you, like initialize the left and the right arrays with -1, and we also initialize the result array with 0, because yeah, we have to calculate. So initialize the result array with 0. Okay, so for the left, now we will calculate the left array. First we will check the leftmost. If the leftmost is a candle, then we will put a 0. If it's not a candle, then we'll put like sorry, if it's a candle, then the index is leftmost is itself, so we put its index. If it's not a candle, then we stick to -1, and then we check every character and see if it's a candle. Then we if it's a candle, then we update the value by its own index. Otherwise, we take the value from the previous one. Okay, and for the same thing we do for initializing the right array. We first check the rightmost character. If the rightmost character is a candle, then we initialize it with the rightmost index. Otherwise, we will stick to -1, and then we read backwards every character and see if it's a candle. Then we'll initialize it with itself, initialize the value with itself. Otherwise, we'll take the value for the next value, right? Okay, and for the plates, we will first check if the first character is a plate. If it's that, then we increase the count to 1. Otherwise, we'll stick to 0. And then we'll start reading from the second plate. We'll start reading, and then every time we get a plate, we'll update the number of plates by 1. Otherwise, the number of plate remains the same. Okay. Now for the queries, we we start reading from the queries array. Every time we read a query, and then the first value in the query array is the left. So this is the left index. So this is the right index. Sorry, this is the left index. So this one is the leftmost candle, right? This one denotes the leftmost candle, and this is the right index. So we get this from the right array, and we get this from the left array, as you can see. Okay, so we get the leftmost candle and the rightmost candle, and we check if any of them is -1, or if the rightmost minus leftmost is not we have to make sure that this is greater than 1. I just showed you in the example. In that case, we just update the results with the total number of plates till the rightmost candle minus total number of plates to the leftmost candle, and we update the result. So we run this for loop and update the result for all the queries, and finally we return the result array. Okay, so I hope you understood this problem, and I suggest everyone to code this, although this is not a very difficult problem, but it's important to code this to make sure that you don't miss the edge cases, and that would be a very good practice. That's it for today, and we'll come back with another problem. Thanks everyone for watching.